Well, hello and welcome to the Smells Like Money podcast. Join me, Suzanne Chin Taylor, the DooDoo Diva, as I interview guests who are making an impact on how we manage and operate systems for conveying and treating wastewater. As a veteran of the wastewater, trenchless, and civil infrastructure industry, each week I'll be bringing you industry know-how from industry pros who know how. Join me each week as I speak with representatives of organizations that are utilizing disruptive or new technologies and methods, and executives who are excited to share how to be successful and sustainable in our vital industry. So whether you want to learn about the latest trends in technology, in treatment or trenchless, gain tips on training and retaining great talent, or simply how to be more efficient, productive, or profitable, this podcast is for you. Ready? Let's dive right in. Well, hello, everybody, and welcome to this week's episode of the DooDoo Divas Smells Like Money podcast. We are continuing our visit today with Robin Deal, product manager of Aquapure of the Hubbard Hall Company. And for those of you who weren't able to tune in last episode when we were visiting with Robin, little background on Hubbard Hall. It is experiencing or celebrating, I should say, its 175th anniversary. And it is still a family-owned, privately held business. And I'm going to turn it over to Robin now to give us a little synopsis of exactly what the company does. And then we're going to dive into today's topic. So with that, take it away, Robin.
Hi, thanks for having me on again. Hubbard Hall is celebrating its 175th anniversary. It started out in 1849 as an apothecary. You can still visit its original headquarters in Waterbury, Connecticut, if you want to go get a Dunkin' Donuts coffee. We manufacture chemicals for the metal finishing industry. The chemicals can be anything from cleaners to rust preventatives, accelerated mass finishing chemistry, metal colorants, and the product line that I manage specifically is wastewater treatment chemistry. When our former owner, who unfortunately passed away a few years ago, Chuck Kellogg, took a look in the early 80s at our industry, he saw that we were contributing to the pollution from metal finishing into the environment. So he made a decision that if we were going to give our customers chemicals that polluted the environment, we needed to help them figure out ways to clean their wastewater up and prevent that pollution from happening. So Aquapure was born from those early days of the EPA from 1972 enacting the Clean Water Act to the pre-treatment programs that the metal finishers are classified under, and Chuck's decision to help our customers clean up their water. His daughter, Molly Kellogg, now here spearheads the company, and her mission statement is to do more with less, whether it's less chemistry, less physical labor, less hazards around the chemistries we use, less pollution. Our goal is to do more with less.
Wow. Well, one of the things when you were saying about contaminants, because we touched on this a little bit on our last episode, but one of the major concerns, I mean, it's a buzzword, it's all over the news, is PFAS. What are we going to do about PFAS? And so if you can kind of maybe give us a little PFAS 101 as it relates to the, metal finishing industry, which is, or industrial chemistry, which is really, your wheelhouse, and what measures can be taken for these types of manufacturers and, their specific type of wastewater treatment can be done to mitigate or deal with all of these new, regulations and, coming into compliance of not producing, or what are we going to do about it? It's basically, so what's the deal with this PFAS and what are we going to do about it?
So I think the first thing that a lot of people don't understand is PFAS is an umbrella term. It encompasses thousands of chemicals, not one chemical. So in the metal finishing industry in the 80s, as a way to promote worker safety for people who did hexavalent chrome plating, the EPA actually mandated that all hexavalent chrome platers use a specific chemical that was a PFAS as a mist blanket to help keep the hexavalent chrome from going into the environment and the manufacturers inhaling it and getting cancer, because hexavalent chrome is carcinogenic. So that mandate came from the EPA in the early 80s, mid 80s, somewhere in the 80 range, to start using PFAS as a suppression blanket on these hexavalent chrome tanks. That is the number one concern for metal finishers when we talk about PFAS. That blew my mind. I didn't know that came from the government, that we had to use these chemicals. So in the 90s, the National Surface Finishing Association said, hey, we don't think this is very safe. And they started researching alternative chemicals to use for mist suppression in the chrome plating industry. And here we are, 2023, decades later, we still haven't found the ideal chemical to replace the PFAS that was mandated to be used in the 80s. But what we have done is we've started moving away from hexavalent chrome to trivalent chrome and other specialty blends to give us that same mirror finish look that hexavalent chrome plating gave us. Unfortunately, because PFAS is a forever chemical and it has been identified as being dangerous for human safety purposes, those guys that did the PFAS mist suppression systems used them for so long that those chemicals are kind of permeated into the tanks, into the piping, the flooring. It's all over their manufacturing facilities. It's in their wastewater treatment facilities. And so to get to the less than part per billion that we're recognizing as the safe zone, a lot of companies are facing having to do total rehabs of their facility, or looking at ways to remove it or destroy it from their wastewater system before it goes back out to the environment.
Wow. That's going to be a huge undertaking. You had mentioned to me something about offline that certain military contracts, for I guess military airplanes or whatever, equipment that they're ordering, that it requires that it have a certain type of chrome finish, and
Yes.
that they're saying you can't use this anymore. The industry is facing, okay, well, I've got this contract that is specifying I must do this. So now what am I going to do? And so economically, what are manufacturers going to do in these cases when these mandates know you can't use this are coming about in states? And, there's so many different layers to this of things that are going to be affected. And so you had mentioned to me that, your firm is involved in some, pilot projects in looking for, and I want to talk about that because this is going to be a big business concern. It's like, okay, it's here. You don't want it here anymore, but it's forever. So now what do we do? Everybody says, get rid of it. Everybody's complaining, but nobody's able to come up with a solution. They all want it rectified, but it's like, all right, we all need to contribute and be part. We're all part of the problem. So now we all have to be part of the solution collaboratively together. Right. And when you mentioned to me what you were working on, I really wanted you to share that, because I think that it is a really good example, because this problem is not going to go away just because we're wishing it away or by legislating, okay, you can't use this anymore. Well, we still need to manufacture these certain things. So we need something else in its place so we can still be productive and meet our obligations to our customers. So how do we do that?
So
How do we do that?
there is a ton of research being done in the metal finishing world on how to treat, remove, destroy PFAS. One of the so we're actually working on two alternatives, getting ready to start a third one. The first one is advanced oxidation, which is chemically destroying PFAS. It's the only way to truly destroy PFAS. But you do it chemically, and it is a kind of complicated process that a lot of metal finishers don't have the space, the time, or the expertise to do. So then we partnered with a startup out of the University of Massachusetts. I think I said that wrong.
It's okay.
But they are, we're getting ready to run some pilot testing with them at some of our customers to use electrostatic carbon filtration to remove the PFAS from wastewater. So that's the second route we're taking. And the third route that we're just now starting to see some research around that we may open up a study on is using bioaugmentation, specifically designed bacteria that will consume the PFAS as a food source. So those are the three things that we're looking at. What will be the best option for customers will be based on their size, their wastewater flow, the contaminant levels, and it may be a combination of 2 or 3 options out there now.
Well, talking about that second one, with that startup, the electrostatic. So what does it actually, silly question. Well, maybe not a silly question because I just don't understand it. So you're removing it from whatever the stream is, but is it then like contained and then you've got to figure out a way to dispose of it? And so then if that's the case, much like other waste that's being like taken off to mountains and buried deep under the ground, is it going to be the same thing with PFAS? Is that, yeah, we're going to be able to find a way to extract it, but then what do we do with it?
So for metal finishers, this electrostatic carbon filtration will, the carbon will hold the PFAS. But the startup partners with other companies that will take the carbon for regeneration, which is where they run an acid and they clean the carbon back up and they remove all the contaminants and they give back clean carbon for reuse. And then that process goes through advanced oxidation, which destroys the PFAS. So it takes that destruction process off of our customers and puts it on one facility that is equipped and able to do those processes.
So this could actually be opening up a whole new industry to just to have a plant when you were saying that would just take that stuff that you were just the carbon and then taking it and finishing what needs to be done to get rid of that PFAS once and for all. Wow. It's a whole nother business opportunity here for those of you listening, thinking about, oh, maybe I should start my own business. Maybe this is an area or a revenue stream that people need to be looking at because there's actually going to be a need for this.
Yes. So, and the really cool thing about carbon filtration and specifically the electrostatic is it can also remove the metal contaminants in the process.
Added benefits.
So we're doing more with less. We're not using as much or even any wastewater chemistry, depending on their contaminant level. The carbon that's sent for regeneration, the metals are recovered and go back into recycling and go back to the customer and they're able to use it again.
Repurpose, reuse, recycle. Oh, wow. So there is a way, we just have to put our thinking caps on that there is a way to deal with this that actually is going to, in the long run, benefit the planet.
Yes.
But isn't it interesting how, when we think about things like this, that they started out with this concept of use this to protect the workers, not realizing that it was going to create a whole different set of problems for the environment down the line. And I guess, with any of these processes that we're looking at, or that you've seen in these pilot studies, is the cure worse than the disease? If you were to compare it like that, what do you see there?
So again, with the electrostatic carbon filtration, I think it's a win-win.
Okay.
We're doing.
How about that first one? How about the first one that you talked about?
So advanced oxidation.
Yes.
Is, total destruction. It's the only process that actually destroys. As of now, technology advances and there's lots of research. So as of right now, it is the only process that totally destroys PFAS. And it is
just requires a big footprint and a lot of CapEx.
And a lot of safety, because it uses hydrogen peroxide
and
iron. And anybody who works with those two products knows that if you put iron in peroxide, it explodes. So you have to have a lot of safety network around these systems. They 100% work. And when the operators are trained on how to properly use advanced oxidation with this combination of chemistry, it's wonderful. Now, there are some safer alternatives to advanced oxidation, such as using peroxide with UV light, which we see a lot of municipal and drinking water plants do now to remove organic contaminants, smell, taste, things like that. There's using.
But does that work with the PFAS?
There's research being done for it.
Okay.
Right now. So is it going to work? I haven't seen a positive yet. Doesn't mean it's not going to work ever. It just means there's so many unknown factors around how to actually destroy these long chain carbons, which is what a PFAS is. It's a long chain carbon chemical.
And I love how I would like you to go back to that, because when you said at the beginning, a lot of people don't understand what is PFAS and that it's a whole bunch of things. Yeah. And so in addition, obviously it's found in metal finishing, but what other type of industries, are using this widespread that you may know of? You may be able to answer this question or not, where they need to be taking a look at modifying their wastewater treatment to deal with this, because I am envisioning that before too long, there's going to be more compliance regulations that if they don't do something about them, they're going to start getting slapped with all kinds of fines.
So the very first industry that started changing how they manufactured their products, believe it or not, was fire extinguishing companies.
Wow. Okay.
Firefighting foam contained PFAS.
Oh, wow.
And so a lot of fire extinguishers that were foaming types of fire extinguishers, and maybe possibly some of the powder extinguishers, the companies went and pulled them offline. They said, we're not going to sell this type of chemistry anymore. So that started happening about 8 or 9 years ago that I'm aware of. The second industry, carpet manufacturing. Scotchgard for stain prevention was a huge contributor to the PFAS situation. And there's a lot of textiles in the Southeast that had to change the way they produced their anti-staining fabrics. From there, we look at things like Kevlar. For our police officers use Kevlar vests. Kevlar had PFAS in it. Teflon coatings for your nonstick cookware had PFAS in it. So it's such a widespread chemical family that we are still last count, there was over 9,000 compounds that were classified as PFAS.
And they're used in our everyday life.
Everyday life. I can guarantee you, if you look around your room, you're going to find some stuff that have PFAS in it.
Wow.
When we talk about things that we've done historically in the past, in the 15, 16, 1700s, women used arsenic to keep their skin pale and clean, right? And they didn't realize it was killing them. That was actually in makeup for hundreds of years. And then we learned, right? We learned from our mistakes. And now we don't put arsenic on our faces to make our skin clear. We're going to find this is the same thing with the PFAS umbrella, right? All these chemicals that we used in the 60s, 70s, 80s that we didn't know were harming us. Now we're seeing, hey, they're not good for us. So we're going to have to educate ourselves and learn how to remove them from the environment safely, to destroy them if that's what it's going to take. And what can we put in place of them that's safer? And that's what the wonderful thing about humans are. We're evolving. Our mentalities and the way we think are evolving. In the 20s and 30s, when plating was first started, they would take their waste and bury it. That's why we have Superfund sites, right? That's why we have all these places across the nation that they're actively cleaning up. We learned that's not good for us. The Clean Water Act came about because we were harming our environment. And then when we realized it, we said, we got to stop and we got to change. And so that's the next iteration of this, is we have to stop using these chemicals and we have to change. That's just where we're at. So now we have to understand the impact on human health these long chain carbon compounds have. And what does that look like for our future and the safety of our children, our grandchildren, our great-grandchildren? How do we help them be healthy and safe?
Wow. You know, I think that this is a really good place to close, because it's left us with a lot of food for thought, because I think just dealing with this issue is going to require some big changes.
Yes.
Not just on industry, but us as consumers, because we drive our desires, our wants, drive what they do. And yeah, we all have to contribute to being part of the solution.
Yes, we do.
Yeah. Well, you know, thank you for this. This was really enlightening. And, you know, I've read about it, but, you know, sometimes I'm sure many others have done too. You know, they read articles about PFAS, and as you're starting to read it, my father was a PhD in chemistry, and sometimes he would start talking to me about things, and he could actually see the glaze start to come up over my eyes. It's like, you know, like I have no idea what you're talking about. And I think a lot of people feel that way about, yeah, I hear that this thing is really bad, and I'm going to pretend like I know what it really is because everybody's talking about it and says it's bad. But I don't think we really, as a society, understand exactly what it is, where it's at, and how widespread and what it's in. It's just, this is shocking to me. Just like in the last episode where you talked about how much water is used to make one car. I mean, you've just, wow. You know, thank you for that, because I do truly believe that a lot of us are just not aware of what is this thing, really.
And I think our industry is learning as we go. So it's every single day I get an update from the EPA on new chemicals being put to the list. Yesterday, I got an update said these chemicals are actually off the list now because they're safe for humans to be in contact with. So It is an ever-changing, moving target to understand right now. 20 years from now, we'll have it down pat. Right now, everybody is learning. We're all in this together, and we all need to contribute to solving the issue.
I love that. I love that. We need to be part of the solution. We're all in this together.
Yes.
And on that note, Robin, thank you so much for sharing your expertise and your knowledge and what your company is doing to contribute to, solving this. And for those who would like to connect with Robin, learn more about what she does, you can find her on LinkedIn at Robin Deal. And if you want to know more about her firm, Hubbard Hall, visit them online at, and I'll spell this out, Hubbard, Hubbard, hyphen. Make sure you put that hyphen in. Otherwise, as she said earlier, you'll get a frat house. Hall, HALL.com. So that's Hubbard-Hall. Thank you again. And for those of you tuning in, we appreciate you. And until next time, keep it flowing. Thanks so much for joining me, the DooDoo Diva, on this week's episode of Smells Like Money. What stood out to you this week? Share your takeaways by leaving me a review. You can find out more about the new technologies, creating sustainable solutions, and insights on how to succeed in our vital industry by subscribing to the show. Whether you want to learn about the latest trends in wastewater infrastructure, treatment, or trenchless, you've got it all right here at Smells Like Money. If you're an industry expert and would like to be considered as a guest for the show, book a quick chat with me by visiting calendly.com/the2it group/B-A-podcast-guest, or simply click the link in the show notes below. Until next week, a big shout out to all my industry friends and those who will be. You are my superheroes. Thanks for tuning in, keeping it flowing, and we'll see you all next week.